All right, welcome everybody to this week's Paleo Talks. I think we're on episode 6, and this week we have special guest, Dr. Grant Zazula, who's joining us from the Yukon. So this will be the farthest person who's actually joined us so far. And he's going to talk about something that I'm passionate about, and many of us are, and that is the Ice Age animals of the Yukon region. And he's going to tell us about where those fossils come from. But before we introduce him, I'll tell you a little bit more about the show. It's brought to you by the Center of Excellence in Paleontology at East Tennessee State University here in Dawson City, where we manage the Gray Fossil Site and our Natural History Museum as well. I also want to introduce David Moscato, who is the co-host, and David is a past graduate student of ours, and he is also our science communicator. David, you want to chime in for a minute and show everybody what you look like?
Sure thing. Hello, everybody. Welcome to Paleo Talks. To give you a rundown of the format here, we're going to start off by Blaine's going to ask Grant a few questions to lead through the topic at hand, and then about halfway through, so 15-20 minutes in, we'll open it up to questions from the audience. So on your Zoom screen, if you scroll down to the bottom, there is a tab that says Q&A. You can type your question in there, and once we start taking questions, we'll read them aloud for Grant to answer.
And I realize we won't do the chat, so go to the Q&A for your questions and answers. All right, let's introduce Grant Zazula now. Grant, if you could just tell us a little bit more about yourself before we get started, sort of where you went to school and where you are now.
Wow, yeah, thanks for inviting me, Blaine. This is wonderful. I'm so glad to be connected to you guys. My assistants, Susan and Elizabeth, were supposed to be down at the Gray Fossil Site for your AMP meeting last couple months ago, a month ago?
Yeah, in April.
I don't know, the last 2 months have been totally a blur, of course. But it's awesome to be connected with colleagues and friends like you guys and to be able to see each other and to tell you a bit about the Yukon. And yeah, so I'm here in Whitehorse. I'll show you a map here in a bit of where I am in relation to where you guys are. But I work for the Yukon Territorial Government. So Yukon Territory is like a state, like a province in Canada up in the far northwest next to Alaska. And I've been in the position running the paleontology program for 13 years. And I came out of Simon Fraser University for my PhD in biology, which I graduated from in 2006. And before that, I was largely an archaeologist at the University of Alberta. So I did my master's in undergraduate work in geology and sort of integrated quaternary science and archaeology back in the old days. And now I'm here and working from home and hopefully going to get back out in the field one day again soon to do some more cool work.
Fantastic. Thanks for that background, Grant. Let's get into the Yukon. A lot of just incredible fossils are found up there, and they're found in a kind of a unique way when we think about fossils from the Ice Age. Could you tell us a little bit about sort of fossils from the Yukon, where they're from and how they're found?
Yeah, definitely. Well, what I'm going to do is I'll pull up my some imagery and give you a chance to see a little bit about how this all works with us. Here we go. So hopefully we can all see that.
Yep.
Excellent. So yeah, so of course I'm from the Yukon. So here's a map of North America, so we all know where we're situated. You guys are down here, of course, down in the lower 48, down in Yankeeville, the United States of America. We're up here north. As you know, Canada, we're famous for lots of things and infamous for a lot of things. We have currently, I think there's now a wall separating us, but I'm not sure if that's true or not. So as you see, we're far remote up in Northwest Canada. It's a very remote place. It's not a typical place that most Canadians think of, but maybe it's kind of the stereotype of Canada because it's cold in north, next to Alaska. Canadians are kind of infamous for all these kind of things like lumberjacks and hockey and dog mushing, but I don't live in an igloo. I can assure you that I don't. So yeah, Whitehorse is a small city of about 30,000 people in southern Yukon. And the two main areas that we do a lot of our field work are in the the Dawson City, the Klondike Goldfields region, which is famous globally for the Klondike Gold Rush of 1898, and which is really where our paleontology research starts in the Gold Rush of 1898. But also the northernmost community in Yukon called Old Crow, which is also very well known for Ice Age fossils and has had a lot of research over the many decades. So, bit about Whitehorse, 30,000 people. It's a tiny little town kind of off in the wilderness. And it's great to be in a place where you can do field work. And, you know, we're in one of the last places left in North America that has true megafauna. We have grizzly bears out my back door and moose and stuff. So it's so amazing to be working and living in a place that has megafauna and thinking about how those populations of megafauna have changed in the north through time. So a bit about our program. So the Yukon Paleontology program, we work closely with something called the Yukon Beringia Interpretive Center, which is our museum, and it's a typical Ice Age mammal museum that tells the story of Beringia. We have fossil collections. Our collections are about 40,000 so far, and we've been accumulating collections for many decades. And really the gist of the story of the reason why we have a paleontology program in the Yukon is because of Beringia. So if we look at a map of North America during the last glacial maximum, say 20,000 years ago, you know, for all of you guys, you'll know, you know, you lived in the southern portions of North America that were never covered by glaciers. But for us Canadians, most of Canada was completely locked in ice for most of the Pleistocene. But if you look at this little corner up here of Yukon and then Alaska, it was never glaciated. So animals had the opportunity to live there in these Arctic conditions through the whole Pleistocene. So it's a really unique region because it was never glaciated, but it was also connected to Asia through the Bering Land Bridge. So it makes it's a really important place sort of biogeographically in North America for understanding megafauna populations, both now and in the past. So I'm going to talk a bit about like the work that we do has largely been centered on the area around Dawson City, which is famous for the Klondike Gold Rush. So this is an aerial shot of the town of Dawson, which is about 1,500 people in the summer. It's a wild place. We hosted the International Woolly Mammoth Conference there in 2003, and I hope to bring it back one day because it is the best place to be in the summer. You can go off, collect woolly mammoths. You can see can girls and gambling halls, and it's like 1898 all over again. You can see this landscape is rolling hills. It's unglaciated terrain, so we don't have that typical glaciated U-shaped valleys like we have in more montane regions. But you can see in the center of this photo those a small-scale gold mining operation, and that's really where a lot of our work takes place. So if you go back to 1898, during the height of the gold rush, this is a common scene in the Yukon. This is what you would have saw. It was people out in the hills mining for gold, digging through the permafrost. And these are largely people that came up from California and Seattle from the gold rushes down in California. And as soon as they started finding gold, they started finding things like this. So I don't know if anyone can notice that, but there's a molar of a woolly mammoth right there on that photo. So there's tons of black and white iconic photographs from the gold rush showing the people finding these incredible Ice Age mammal fossils. And of course, when they arrived in Dawson to gold mine, they encountered the Trondheim people, which are the local Indigenous population. And they're still there today, and they're very important research partners in the work we do. And this is what Dawson would have looked like. There was maybe 6 or 7 people, a small family living there. And then at the height of the gold rush, that summer of 1898, 40,000 people showed up to look for gold. But I'm sure when they looked for gold, the most impressive thing in their minds must have been these awesome fossils of Ice Age megafauna. And for example, this incredible skull of a woolly mammoth. And that's really where the paleontology program starts in the Yukon, is that gold rush interaction between Indigenous people, gold rush miners, and then soon thereafter, all these scientists showing up.
So
media
Grant, are there stories about the Indigenous people already knowing about the fossils, or is it something that was just discovered because of the blasting away of the sediments looking for the gold?
Yeah, that's a really great question, Blaine. So, you know, in the Klondike region, that ground is permanently frozen. It's permafrost, and there's not a lot of natural erosion taking place by the rivers. But if we go further north, I'm going to show you something else. Back in the northernmost part of the territory, I just zipped through a few slides. The northern part of the territory, that's sort of as you get into the tundra zone near the village of Old Crow, you get these long undulating river systems like this, where you can see these amazing exposures of quaternary sediments. And like right after the gold rush, the Smithsonian went up there, and they were amazed by how many fossils they were finding. And one of the neat things about it, though, is the connection to the indigenous people, because remember, these are people that have been using canoes going up and down the river, walking up and down the river for 15,000 years. And these fossils get naturally eroded out of these river systems. So there are some images here of us working with the Vuntut Gwitchin First Nation, and they have amazing stories about giant beavers and small beavers, you know, some at the end of the ice age, these giant animals becoming magically transformed into small animals. And you know, that's one of the cool connections of our work is with the indigenous people, because you have to imagine, like, these are people, when they go shoot a caribou, that thing is carved up within minutes. They know vertebrate anatomy better than you and I. Mm-hmm. So when they see a femur bone that's this big mm-hmm. on the side of the river, they must have went, oh, there was giant monsters back then. And that's exactly kind of the stories that they tell us about these giant monsters. And it's really cool to hear about them and how those stories have been passed on for the generations. Yeah.
So you mentioned, Grant, the permafrost, but people on here might not know exactly sort of how that works and how that preserves the fossils. So if you could go into a little detail about that.
Yeah, definitely. Yeah, so like our program, we spend a lot of time out in the North Yukon working with the Vuntut Gwitchin on the rivers. We also work in the Klondike gold fields out in the gold mines. And you can see as we're in this image here of us walking around, that those hillsides are totally frozen. So permafrost is ground that's frozen throughout the year. And it's essentially like a deep freeze. So animals that would have lived and died 20,000, 30,000 years ago, when they died and their bodies were decomposed and then scavenged or whatnot, their remains would have been locked in ice. And so these valley bottoms that we work through, the biggest challenge for gold miners to get rid of that permafrost so they can get at the gold bearing gravel that's underneath. But that's really our record of the ice age is preserved in that frozen ground. So this is a map here showing permafrost distribution in the Northern Hemisphere. So you could see in the central Yukon, North Yukon, we're sort of in the discontinuous or continuous permafrost zone. And this is what permafrost looks like when these miners blast the hillsides away. As these, this is frozen mud, that's silt, it's lust from the ice age. So windblown silt that was deposited in valley bottoms. And then these giant ice intrusions would develop in them. And so you see these massive ice bodies, which are 30 or 40,000 years old. And we call it black muck because in the summer when it melts, you can see we're up to our knees in the stuff. It's like a slurry of ice age, stanky mud. And it's like organic rotting stuff that it's like a barnyard in the spring when it melts. And it just stinks. And it's amazing because it's the smell of the Pleistocene. It's the smell of woolly mammoths. And
wow.
It's we know that based on some of the stratigraphic studies, that ice has been there for almost 750,000 years. So we know that anything that lived and died during that time has a really awesome opportunity to be well preserved. I'm going to show you kind of what it looks like. This is how this works.
So how much time do you and your group get to spend there every year?
So my two assistants, Elizabeth and Sue, that do most of the field work, they're out in the Klondike goldfields from June till September, just hanging out with miners, driving around, visiting sites. And and seeing what can be found in the permafrost. And it's quite, it's amazing. Every summer we collect about 6,000 or 7,000 individual specimens, and we have a lot of work to do to deal with them. As you know, dealing with collections is a wintertime job or a COVID-19 job.
Is this collection program something that's been going on continuously for a really long time, or is it something that you've started?
Well, back in the old days, during prior to 1996, the National Museum in Ottawa, Canadian Museum of Nature, really had the responsibility of dealing with fossils from the Yukon. So a lot of those collections, those early collections that were made by people like Richard Harrington, who's a Canadian legend in paleontology, all those specimens are in Ottawa. But now, since 1996, the program in Yukon was established, and all the material that comes from the Yukon now stays here. So we have a collection of almost 40,000 specimens now, and it grows a lot every summer.
Okay.
Yeah. So yeah, permafrost. It's awesome. It's the bomb, as kids would say.
Well, it certainly is for the ancient DNA work.
Yeah, definitely. And that's what one of our biggest markets, I'd say, now for a lot of the material that we find is ancient genomics and the preservation of ancient DNA in bones. Because back this material, since it was frozen largely soon thereafter the animal died, those biomolecules are so well preserved in the permafrost that they remain for hundreds of thousands of years. So it's really a big part of what we do, is working with geneticists. And like Yukon has the oldest DNA ever sequenced in the world, and that's actually from a horse bone, and I have it right here. You can see that. That's the Thistle Creek horse bone. It's over 700,000 years old and has the oldest genome ever sequenced in the world.
Could you unshare your screen so we can see it larger?
Sure, I'll do that. Yeah, so this is the Thistle Creek horse bone. I don't know. It was a part of a metacarpal that's been totally hacked away by previous sampling, but it's proven to be our most valuable bone in our collection because it has very well preserved DNA and it's that old, 700,000 years old. So we're pretty excited about that. But the other thing about permafrost is that it's not just about preserving bones and DNA. It's about preserving mummified carcasses. And we all hear about these fantastic stories from Siberia where they found these complete mammoths. Like this is Dima here that was found in the 1940s, I believe. And you just look at these folks, like I love dressed in shirts and ties out there in the Siberian tundra, and they find this baby woolly mammoth. And we get jealous because we have permafrost in the Yukon and in Alaska too, but we don't often find mummified carcasses. And that situation of permafrost mummies is so prevalent in Siberia, but not so much in North America. But we do find some things, and this is an example of the skin of a mummified Ice Age horse that was found in 1993. So we can see the skin preserved. There's the tail with some of the hair, articulated limb elements, and this one was radiocarbon dated to about 30,000 years old. So you can just rip the flesh off that and eat it like it's beef jerky, and that's exactly what people like Dale Guthrie did when they had Blue Babe. I think I have a photo.
All right, now you have to tell that story, Grant.
I will, but I'll tell you that story in a second after I show you these guys. So this is what we've called, it's actually named Jur in the Trondic-Wichin language, and that's the name for wolf pup. And this is a specimen that was found in 2016 by our friend Neil Lovelace, one of the gold miners. And he saw this odd thing popping out of the hillside as he was using his water cannon to wash away the mud. And this popped out. He thought maybe it was a dog, like a dead dog. And it turned out to be a mummified, complete wolf pup that's radiocarbon dated to over 50,000 years old. And yeah, we're doing some amazing genomic and stabilized work on it right now to learn more about it. We know it died at 6 weeks of age, and she probably died of starvation. And yeah, she's got an interesting phylogenetic story of movement of wolves across the Bering Land Bridge, which we're writing up right now. So yeah, the permafrost, it's wild. It preserves some amazing stuff. We found a caribou that same year. It's a piece of the caribou. that's found beneath a volcanic ash that's over 80,000 years old. So yeah, that opportunity to find preserved animals is pretty wild, because when you look at something like this, like, you know, especially I'll go back to the wolf pup, it's one thing to look at a bone of an ancient animal, but when you have the whole body staring at your face and you can actually connect with it, that this was a living animal, and imagine how it was running around and breathing, especially running around and eating beneath the foot of woolly mammoth. And it's wild to put it in that paleo environment when you have the flesh to work with. Yeah, this is another example of a mummified specimen that I got a chance to work on. It was actually, I spent my 30th birthday in 2007 or so, I don't know when that was, up in the community of Sikajik, which is in Northwest Territories, just on the other side of the border, but still within that partially unglaciated terrain. And this was found by a young man as part of a skeleton, and we had a part of the fur. But this is the oddest mummified specimen I've ever had my hands on in my life. And we thought at the time we had parts of the hair, we had parts of intact limb elements, and it was about 14,000 years old. But this turned out to be, I thought it was a part of a lower intestine, but when we had a veterinarian dissect it, it actually turned out to be a mummified penis. So this is a steppe bison penis from 14,000 years ago. I think it's kind of strange that I had a bison penis in my hand and I didn't even know it. It may be, I think it's the second mummified Pleistocene penis known in the world, because there's one in St. Petersburg of a mammoth on display as well. Yeah. So that's the permafrost, Blaine. It's a lot of fun to work with, and I hope one day that we can bring you up here and see what it's like to discover fossils in the frozen ground.
Yeah, well, I definitely want to. And I think one of the things that a lot of people are curious about is this concept of have people more recently eaten some of these.
Yes, okay.
Or we know the story of Guthrie, but if you could quickly tell that story, and then we'll open it up to questions from the audience. Yeah,
definitely. Back in the early 90s, or I guess the late 80s, Dale Guthrie, who's the godfather of Beringian science, really, in Fairbanks, University of Alaska Fairbanks, a gold miner found a complete carcass of a steppe bison, an ice age steppe bison, that was radiocarbon dated to about 40,000 years old. And when he did an anatomical dissection of it to do an autopsy to figure out how old or how this animal died. And he figured, well, I'm a paleontologist. I get a chance to work on something like this. I'm going to cut a piece of the meat off. So they cut a piece of the hind limb off from the rump roast, and 40,000-year-old mummified freeze-dried flesh, and he boiled it up. It made a stew out of it. And I remember him telling us that it was the most terrible tasting meat he had ever eaten in his life, the most terrible tasting stew, but it was the most satisfying meal he had ever eaten in his life, just because wow, 40,000-year-old flesh, that's amazing. So that's probably the best story of eating mummified meat from the permafrost.
Well, thanks for sharing that. Well, let's open it up for questions from the audience.
All right, we have a few questions coming in on the Q&A. Before I do that, there is a quick question that I want to confirm with you, Grant. That horse bone that you held up, is that the bone that was sampled for DNA?
Yes, it was. Yeah, this has been sampled, I think, 4 times by different genetics groups, and every time we sample it, the quality of the genome gets better and more information comes out of it. So yeah, it's kind of one of these things, like, I know some curators get pretty concerned about sampling, but our feeling about it is that, every time you sample, the opportunity to get new information is just so invaluable that I think the value of the data is probably more than just this. It's just a scrappy little bone. It's not like it's a museum quality thing you'd put on display because it looks pretty. It's
right. That's amazing.
Yeah.
All right, we've
Yeah.
got a bunch of questions rolling in. So as a reminder for everybody, if you scroll to the bottom of your Zoom screen, there is a Q&A tab where you can enter questions. First, I'm actually going to read out a question that I will provide the answer to. Will we archive this presentation? This will be on YouTube. So keep an eye out. Next week, we will upload the whole talk recording on YouTube. So questions for Grant. This one comes from D. Smythe or Smith. Are the fossils protected by legislation or laws that restrict where they can go or who can collect them?
Yeah, that's a really good question. So I'm just gonna put on a different image here. So in one of the things that makes Yukon really unique in Canada and North America is that we have modern Indigenous land claims. So in the mid-1990s, some land claims were established between the government of Yukon and Canada and the local First Nation or Indigenous governments. And part of that was to create legislation that protected fossils and archaeological artifacts and historic sites. So yeah, in 1996, legislation was passed in Yukon that basically ensured that all fossils found in the Yukon would remain in the Yukon and are protected from disturbance and from private sale and private ownership. So yeah, now we have a really good working relationship with the industries like mining industry and the gold miners out in the Klondike. So yeah, when they find things, they give us a call and they're really excited to report what they find and to learn more about the discoveries. So when we do scientific studies on them, we make sure that they get that information and they're acknowledged. So yeah, it's, in some places, there's a lot of conflict between industry and things like paleontology, and often legislation doesn't quite work. But I think in Yukon, it works quite well because, yeah, definitely, I think the scientific results kind of speak for that because with the participation in the kind of respectful collaboration between the miners and the government, regardless of any legislation, it wouldn't matter. I think it's really built on respectful relationships. And yeah, we kind of all see it as we're working together to do this kind of research.
Excellent. We've got another question from David, who's one of our volunteers and I believe occasional actual paid workers at our museum. He asks, how is climate change affecting the permafrost matrix of Yukon fossils?
Yeah, that's a really good point. So permafrost is largely stable until it's disturbed. And it can get disturbed in a few different ways. And one is through natural erosion of rivers. So we see where rivers are cutting into permafrost, we see a lot of melting going on right now. And that's causing some problems because in some cases we've seen rivers become almost dammed by permafrost mudslides. Yeah, so it's causing some problems. We're seeing a lot of effects on the highway, like permafrost melting and heaving is a real problem for infrastructure like that. And I suspect as we see more melting going on in the future, we're going to see more fossils coming out of the frozen ground. So that only creates more work for paleontologists and more possible research to come out of it. So that's not, that's one of the positive spins of climate change and global warming is melting of permafrost. We're going to get some cool fossils out of it.
Here's another question via Amy, but from Collins, who is 8 years old.
Hey.
What is the range of temperature on the tundra? Is it different than what it was when these animals were alive?
Yeah, so a lot of these animals were living during the time we call the last glacial maximum, or during the Pleistocene when it was colder than present. And yeah, I think the main thing, like one of the unique parts of our climate up here is that in the winter, it's dark, almost dark all the time. We have almost continual darkness for a few months in the winter. But in the summer, it's continually light. Like right now, I can read a book at almost midnight outside. So that really has a lot of effect on the climate. So the temperature situation is quite interesting because if you look back at during the last glacial maximum, it was probably a lot colder, maybe 6 degrees colder. But even if it's 6 degrees colder, if you have light in the summer, it's really bright outside, you're still going to get a lot of ambient warmth from the sun. So yeah, the conditions the animals faced back in the Pleistocene were definitely different. There was probably a lot less, temperature may not have been that important, but precipitation was probably the major thing. Because right now we get a lot of moisture and we get a lot of swampy grounds, muskeg and ponds. But during the Pleistocene, it was incredibly dry. There was almost probably very little precipitation. So there was almost very little snowfall in the winter. So without a lot of snowfall, the ground would have been exposed and animals would have been able to eat brown, dry grass. So having less precipitation, less moisture may have made the environment a lot more habitable for these animals, even though it was colder.
All right, we have a question from Orion that sort of goes along with that. He's asking, why were parts of Alaska and Whitehorse not frozen over by the glaciations?
Yeah, that's a really good question as well. And that has a lot to do with climate. So if you look at the region today, we're almost in a kind of semi-desert climate. It's quite dry, and that's largely because of a rain shadow effect. So any moisture that's evaporating off the Pacific Ocean, the North Pacific, gets caught up in the mountains. So we have huge glaciers in the mountains. And this mural that you see right here shows the mountains in southern Alaska and the Alaska Range. And those mountains during the Pleistocene would have been glaciated because the moisture coming off the North Pacific would have fallen as snow in the mountains and then created ice. But it all got trapped in the mountains. So by the time the winds got into the interior of Alaska and Yukon, there was no more moisture. It was too dry. So essentially, during the Pleistocene, interior of Alaska and Yukon were cold enough to support glaciation, but it was too dry. There was no moisture to grow glaciers because you need cold and moisture to grow glaciers. So it became this incredibly arid semi-desert, and the word we use is a steppe, the steppe grassland. So it was an arid steppe tundra. So precipitation seems to be the limiting factor, the major environmental factor that controlled how ecosystems functioned and determined whether glaciation happened or not.
Mm-hmm.
All right, I think we should be able to get through one or two more questions before we officially end our recording. Here's one that has been asked twice. Two different people have asked. Everybody likes megafauna and big animals, but do you do much work with microvertebrate fossils? Are there anything good found up there? Any good work going on?
Well, my assistant Susan, she's completing her master's degree in paleontology, studying microtine rodents from Old Crow, and she's working on a really cool assemblage that we excavated a few years back, and it was excavated sediment bed associated with something we call the Old Crow tephra. And Old Crow tephra is about 140,000 years old. It's a volcanic ash that came from Alaska during the Pleistocene. It was a volcano exploded during the Pleistocene, and the distal tephra spread all over Yukon, and it's about 140,000 years old. So it's a really good time marker for the last interglaciation. So the time period when it was warm like it is today. And she's studying microtine rodents from the last interglaciation to determine how their range has changed through Pleistocene warming intervals. And so we can see how that compares with modern rodent communities today in the north.
Outstanding. Well, I can't let you go on without talking about Arctotis now that I see it.
Well, yes, I thought I'd show you one slide of Arctotis there.
And you also have a specimen there, right?
I do. Yes, I'm gonna unshare my screen and show you this bone. So this is a humerus bone. So this is the upper arm bone, of course. So for those, this is the upper arm bone. It's broken at the end, so the proximal end is broken. And as a way, this is of Arctotis, the giant short-faced bear. And I'll show you a comparison. So we have an osteology collection that has modern animals from the Yukon, and this is a really good-sized male grizzly from the Yukon. So a big brown bear. So this is a really good example showing how huge these Arctotis giant short-faced bears were up here. And I think, they were so big that even people like Dick Harrington at the time gave them a subspecies name, Arctotis simus alaskensis. And I don't know, nobody really uses that anymore, but I think it just shows how big these animals were during the Pleistocene period.
Yeah, eventually they started using it as Arctotis simus yukonensis. And,
yeah.
And then originally Lamb had described it as a new species based on its size.
Yeah, definitely.
Yeah. And do you have that original specimen?
I don't. That's actually the crania. I'll put is this one right here that Dick Harrington's holding. So that was the type specimen.
So that is it. Wow.
Yeah, yeah, and this is the illustration showing like comparison of coastal grizzly or Alaskan brown bears and black bears, and yeah, so yeah, they're big animals. I know you're curious, Blaine, but this is our current radiocarbon distribution of short-faced bears in Alaska and Yukon right now. So we based on all the radiocarbon dates of, I think, every specimen we've been able to get our hands on of short-faced bears from Alaska and Yukon, and we could see that they drop off around 24,000 years ago. And I think you guys have short-faced bear right up till 11,000, right down in the lower 48. So that's actually one of the lessons we're learning. We've been doing a lot of radiocarbon dating in the last few years, and we're seeing evidence for a lot of the extinctions happening up north at much different times than what you guys experienced down south during the Pleistocene. So those continental extinctions weren't actually synchronous across the entire continent. They're happening at different times in different regions, especially up north.
All right, well, we better wrap up the recording part, and then we'll stick around for a little bit after that to answer additional questions. Yeah, good? We on track for finishing now?
Yep, we can go ahead and wrap it up. But we still have a bunch of questions in the Q&A. So if everyone can stick around, we'll answer some more.
So,
yeah, I brought a bunch of specimens I can show folks too.
All right. Well,
how about I'll pop?
If you want to throw them up right now, go ahead.
I just wanted to show you one thing. Was my examples of Pleistocene woolly mammoth hair that were given to me by a colleague in Russia. So we have the long guard hair, the outer guard hair here, and then some of the under fur here. And this is part of the Yukagir mammoth that was found in Siberia that was documented on Discovery Channel by Dick Moll back in the early 2000s.
All right. Well, again, thank you for coming on. It's been fantastic to hear about this from you. And we'll stop the recording and people can stick around to ask more questions. Thanks, Grant.
Yeah, thank you.